Fourth grade ancient math lesson 12.2. Represent hundreds as fractions and decimals. I can use a visual model and decimal notation to represent fractions, mixed numbers, and decimals in hundreds. So this is literally just like what we did yesterday, except for yesterday we went to the tenths. And tenths is how many places past the decimal? One. So hundreds is 2 places past the decimal. Okay? So it's just like yesterday, except for we're adding one more place value. Okay? So start your learning. Potassium is an important nutrient for our bodies. It supports muscle strength, fluid balance, and energy levels, among other things. The amount of potassium in a medium-sized banana is about 4/10 gram and 5/10 gram of potassium. What could be the number of grams of potassium in a medium banana? Represent the possible number of grams of potassium on the number line as a fraction and as a decimal. Okay, so it says it has to be between, it has to be between the 4/10 and the 5/10, right? So we can just pick a number between there, okay? Because they didn't give us an actual one. So we could say it could be like 4,600, okay? Because it's 46 between 40 and 50. Yeah, so they gave us 4/10, right, guys? But 4/10 can also be 40/100, all right? Because that 0 behind is just holding a spot. Okay, so in decimal form, that can happen. Now, if the 0 is before, then that makes it a different number. Okay, and this is also equivalent. 5/10 can also be equivalent to 50/100. So basically, if I were to take a square or a rectangle, okay, cut it into 5/10, or if I cut it into 50/100, either way, it would be colored the same. Does that make sense? Okay. All right, so they're equal. So here I have my things, my little tack marks on my number line, right? Okay, so this first one would be what? 1/10, 2/10, 3/10, 4/10, 5/10, right? 6/10, 7/10. So here would be my 4/10, and here is my 5/10, correct? Okay, now we also, once again, have already said 5/10 is equal to 50/100 and 4/10 is equal to 40/100. Okay, so would 46/100 be between those two? Yes. So my 46/100 would be right here on my number line. And then how do I write that as a fraction? How many parts? 100, right? So that goes on the bottom. And then how many pieces do we have? 46. So that goes for the numerator. So learner seating number 1. A jar contains 6,500 liters of fresh squeezed orange juice. Represent the amount of juice on a 100th model and a number line. So they were nice enough to go ahead and draw that out for us, because if we had to draw that out, would it be a lot of little tack marks and a lot of little boxes? Yes. Okay, so 6,500. So each one of these columns is how many little boxes? 10, right? So I'm going to need to color in 65. So I'm going to need to color in 1. There's 10, 20, 30, 40, 50, 60, and then 5 more of the next one. So is that 65?
Yeah.
Yeah. So we count our 10s and then do however many extra little ones we need, right? Okay. Now, each one of these bigger tack marks on our number line represents what? A 10, right? So the first bigger one is 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, right? Okay. So how many tenths do I need to go over? 6, right? So I'm going to come over 1, 2, 3, 4, 5, 6. But is that where my dot goes? No. I need to go over 6/10 and then how many little tack marks for 100? 5. So 1, 2, 3, 4, 5. So I'm going to put a big dot there, and then I'm going to label that as what? 6,500, and then fraction form, 65 over 100. Okay, so real quick, connected vocabulary. 100 is one of 100 equal sized parts in a decimal. The first digit to the right of the decimal point is the number of tens, right? So we talked about that yesterday. One place after is tens, and then 2 places after is the hundredths. Okay? So letter A, how would you describe the tick marks on the number line between the tens? So we just talked about that, right? Okay? So the bigger sections were the tenths, right? The littler tick marks were the hundredths. Okay? So letter B, between which tenths did you locate the number on the number line? So we went over how many tenths first? 6, right? And then what would be the next tenth? 7, right? So how many tenths and how many hundredths represented 65 hundredths? So how many full bars did we color in up here? 6. And how many little boxes did we color in of the next one? 5. So if we were going to write that in decimal form, we already did write it. But what would we write? Did we have a whole box? Nope. So there was no ones. Decimal. How many tenths? How many full tenths were colored in? 6. And how many small boxes of the next column were colored in? 5. Number 2, the hundredths model represents the length in meters of a watermelon vine. Okay? So how can you describe the length of the watermelon vine using words? So how many full boxes do we have colored in, guys? 3 full boxes colored in, right? And then how many small cubes do we have colored in? 4, right? Okay. So when we go to write this, let's say it is a mixed number. So how many full boxes did you tell me I had colored in? 3. And that is my whole number. So does it have to be bigger than the fraction when I write it? Space-wise, does it have to fill up just as much as the fraction? Can I write a little 3 and then the fraction? No. Why not? Because then that makes it look like it's in the numerator, and we don't want it part of the fraction, right? So then my line. And then how many total pieces do I have in those boxes? 100. And how many small cubes are colored in that last box? 4. Okay. Now to write this as a decimal, do I have full boxes colored in? Yes. So that number goes to the left of the decimal in the 1 spot. Do I have any full columns colored in that last box? No. So I put if I said no, what do I put? A 0. Okay. And then how many small cubes are colored in? 4. So fraction form and decimal form, we say 3 and 400. All right, so check understanding. Number 1, a grapefruit has a mass of 2,300 kilograms. Represent the mass on the hundredths model. Write the mass as a decimal. So how many full columns do we need? How many tens do we have? 2, right? So I'm going to color in 2 full columns. How many hundredths do I have? 3. So in my next column, I need to color in 3 little boxes. So do I have a full box colored in? No. So I don't have a whole number, so I put 0, decimal, and then how many full columns did I color in? 2, 10, and how many small cubes? 3. So my answer is 2,300. Number 2, represent 73 hundredths as a fraction and as a decimal on the number line. Okay, so do I have a whole number? No. So will I go past 1? No. Okay, now the bigger tack marks represent what? 10. Okay, so I need to go over 7 sections. So 1, 2, 3, 4, 5, 6, 7. So I made it to there. But now how many little tack marks after do I need to go? 3 for my 100. So I'm going to draw a dot there, and then I'm going to write it as 73 hundredths in decimal form. And then how do I write it in fraction form? How do I write it? 73 over 100. On your own, a baker buys blueberries from the farmer's market. The hundredths model shows the mass of blueberries in kilograms. Write the mass as a mixed number and as a decimal. Do we have completely full boxes colored in? Yeah. 2. Yes. How many? 2. So I'm going to put 2. And does it need to be a little bit larger than the numbers in my fraction? Yes, because some of you were writing them really small yesterday, and then it looked like part of the fraction. And does that work? No, a mixed number has a larger number and then a fraction with it. Okay, how many full bars are colored in the 3, right? Okay, how many little pieces of the next column are colored in? 6. And then how many total pieces is that box broken into? 100. Okay, and then how do I write that as a decimal? Do I have a whole number? Yes. Yes. What is it? 2. Okay, decimal. And then how many hundredths do I have? 36. I have 36 little boxes colored. Number 4, Marty spends 58 hundredths hour picking raspberries. Show the amount of time as a fraction and as a decimal on the number line. Okay, so once again, the bigger tacks represent what? Tenths or hundredths? Tenths. Okay, and the little smaller ones represent hundredths. So how many bigger tacks do I need to go over? 5. So I'm going to go 1, 2, 3, 4, 5. And I at least need to be at that point, correct? Then how many little tacks after that 5 do I need to go over? 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to be what? 2 away from the next bigger one. Okay. And then I write 5800 in fraction form. How do I write that in decimal form? Do I have any whole numbers? Have I made it to 1 yet? No. So I have to put a 0 to say, nope, I haven't made any whole numbers yet. Okay, and then out of how many hundreds? 58. So 5, 10, and 800. Okay. Number 5, they want us to shade the hundreds model to show 2 and 8500. So what do I do with this first box? Shade the whole thing, right? So lightly shade the whole thing. Okay, what about the next box? Lightly shade the whole thing. Okay, the next box, do I shade the whole thing for it? No. How many of the longs do I need to shade? 8. I need to shade 8 of those completely in. So I'm going to go all but 2 of them, right? Completely shaded. How many of the next column or long do I shade in? 5. Okay, so they want us to write that decimal as a mixed number. They already gave it to us in decimal form, right? Okay, but they want it as a mixed number. So what is my whole number? How many are completely colored in? 2. So remember, that has to be a little bit bigger. So remember, your whole number has to be bigger than some of the numbers in your fraction, right? If you don't, then it starts looking like the fraction. So what goes on top? 85, because there were 85 little boxes colored in that last one. And then how many little